So if I gave you this system of equations to solve, most likely you'd flip out. And you know, it's already hard enough to do a system of equations because of all the places that you make a mistake. You know, I would argue that the steps are not hard, but as soon as you make one multiplication error or you forget your signs, all kinds of bad things happen. And then on top of that, I gave all of your coefficients as fractions, and I know how you guys think about fractions. So I wanted to show you another option on solving system of equations. And we're going to use this idea that we've been talking about of matrices. If you look at this, I think one of the things that is always the same for our systems of equations is that we always have an x, we always have a y, and we have a z. And you notice that I've told you before that we like to keep these things lined up. Now, as long as you've been keeping them lined up, you probably notice that the x's never change, the y's never change, the z's never change. The only thing that's different in two different problems is just the coefficients, and then the numbers over here are always different. So we don't even really need those variables at all. We can just go straight into a matrix and just use the coefficients. Now, remember, matrices are rows by columns, and I'm going to say this is 1, 2, 3 rows, 1, 2, 3, 4 columns. And so I'm going to make a matrix, a 3 by 4 matrix, that looks like this. And notice that this entry has a negative. It's a subtraction sign in the equation. It's a negative as an entry in your matrix. If there was no variable there, you would add a 0. So if you had an equation that had, for instance, in this one, if this wasn't even there, if there's no z at all, you'd still have to enter it as a 0 here. And then we're going to enter our final column is just going to be the equal signs. So again, make sure it has to be set up this way. I said before that, as long as it's set up the same, if all equations were the same, then you were good to go with elimination, which is true. But if you're going to use a matrix and a graphing calculator, it has to be set up where the x's come first, and then the y's are second, then the z's, then the equal sign, which would be kind of right here, and then the answers. It does not work if you don't set it up this way. So on the next slide, I'm going to take this matrix and I'm going to show you how to plug it into the graphing calculator to get your x answer, y answer, and z answer. Make sure you click on the screen to get the video to play, and if you want to go full screen.